right, so let's get started. Hi, everyone. I'm super excited. I'm super excited to be able to speak in front of you today, especially because this conference, ngAtlanta, has played a very important role in my life and had a huge impact on where Nest is right now. Today, I will talk about dependency injection in Nest in Angular. It's going to be a sort of intersection and mismatch. Before we proceed to the main topic, I would like to quickly introduce myself. My name is Kamil. Daily I work as a full-stack software engineer. I'm also doing some consultancy, training stuff. I'm mainly focused on the web-related things, web technologies. You can find me on Twitter using highlighted Twitter handle and obviously on the GitHub. Beyond regular day-to-day work, I'm giving the value back to the community as an open source contributor. I'm the creator of Nest.js, which is basically the fastest rising and the most popular Node.js framework in 2018. In the previous year, we have noted almost 300% growth in the number of GitHub stars, leaving behind any other existing Node.js library. I'm really proud of it, including Express, Koa, Happy.js, all of them. Regarding Nest, just to give you a short overview of the framework is written entirely in TypeScript and is heavily inspired by Angular. Like, it's taking what's best in the Angular world and putting it into the Node.js to allow people building server-side applications in a similar way, in a similar fashion. However, I will not go through all features of Nest. I'm not going to explain how it could potentially help you, because we had a great talk about Nest yesterday. Today, instead, I will dig into the dependency injection, to the future which overlaps between Angular and Nest. So we will have a sort of deep dive into this future in both frameworks. And the dependency injection, just to give you a short introduction, is an important application design pattern. It helps us creating flexible, scalable, and testable systems. And both Angular and Nest have their own dependency injection systems behind. They are completely different, even though the API looks almost the same. Let's consider this simple example. We've got a regular class that makes use of two different dependencies. It has an HTTP service, respectively, and logger. Both are immediately instantiated in place within the body of the class, which means that every time when we create an instance of the cat service, we'll also create instances of these two things inside. And we already know that this approach is not very maintainable, it's not very testable, and makes creation of comprehensive software tougher over time. Therefore, both frameworks supply us with the dependency injection mechanism. Now a class asks for dependencies from external sources rather than creating them inside. The question that we should ask ourselves is, how is that even possible? That either Angular or Nest knows that we want to inject HTTP service at position number 1 and logger at position number 2. How is it possible? So basically, it all boils down to the compiler metadata, or even to be more precise, to the metadata produced by the TypeScript compiler. Basically, TypeScript compiler is able to emit some serialized design time type metadata. Let's have a look at this class once again. This is what will end up in our final bundle after the TypeScript compilation process. As you can see, various things are happening around cat service class. We've got two helper utility functions, which are generated by the TypeScript compiler by default, decorate and metadata. Obviously, you have set some flags in your TypeScript configuration, like emit decorator metadata and stuff like that. These functions are usually located at the beginning of the file. They are doing some usual things underneath, like checking if the reflect object exists on the global scope and stuff like that. Depending on this, they will attach the metadata to class in different ways. However, the most important thing here is this part. Design param types is a TypeScript metadata key used for parameter type metadata. And regardless whether it's a constructor or just a normal method, we always use design param types key. And the second argument is an array of dependencies that should be injected into this class. So as you can see, we've got this information in the runtime. We see that the order was preserved. We've got HTTP service, and the second element is a logger. So we can see that it was kind of extracted from the constructor at the compile time. Taking a step back to our class, we already know that this metadata exists, this information exists at the runtime. How can we take advantage of it? So TypeScript gives us a polyfill, a metadata reflection API that enables us to put some meta-programming on top of JavaScript. And it's all about providing a consistent, simple, straightforward approach to reason over metadata. Using metadata reflection API, we can get constructor parameterized. If we put these design parameters, this key that I've mentioned a few slides ago as a first parameter, and our class, our random class as a second one. In this case, it's just cat service. You can see that it's going to return us an array of types that we can use to indicate what dependencies are required in this actual context, in this actual cat service. It's an array with HTTP service and logger. And now things become very simple. Let's imagine that we have an inquirer, let's say cat service that needs these two dependencies. It goes to injector. Injector asks for both dependencies by type. And the container is a sort of maybe a map collection which has a key and value. And the key might be a type, while value is an instance of this type. So for example, the key might be a cat service, and the value might be a new cat service. Obviously, it's a very high level, like a proof of concept, how you can implement dependency injection in your application. Both Angular and Nest are doing some heavy lifting behind, like how to handle circular dependencies and stuff like that. It's just to show you how it's going to basically work. So then the container returns the instance. The injector can create a final instance of the class. All right, let's have a look how the frameworks deal with this TypeScript design time metadata. Nest is using this API directly, so there is nothing to explain. It's the same as in the normal TypeScript compilation. We don't have a dedicated compiler. We do not perform any post-processing. If you dive into the files compiled by the Angular compiler, you will see something like this. It's still the same output with one small difference. Both utility functions are imported from the TSLib. They just don't want to put it inside every file just to ensure that your bundle is not that big. Nonetheless, if we move to the ngFactory file of any Angular component, we'll see that the dependencies are represented in a slightly different way. This is an instruction generated by the Angular 7 compiler. We have a compage component here and two constructor dependencies, change detector ref and router. So as you can see, Angular performs some post-processing, has additional compilation step, which no longer uses design param types directly for a few reasons, actually. Most importantly, because of the performance. So Angular has its own compiler to ensure that your application is going to run fast, that it's going to be easy to compile even just in time to give you a first meaningful paint as soon as possible. All right, it would be too good if everything was so simple. It's not, because there are problems on the road that we can face very often. First of all, let's talk about interfaces. This is our previous example. We are going to switch from HTTP service now to the iHTTP service interface. Regardless of the naming conventions, I do not personally use I before every interface. But anyway, it's just to clearly indicate that we are using interface right now. Now, let's reflect our constructor metadata once again. And what? It turns out that we have an object. We no longer have a reference to the type, because interfaces do not exist in the runtime, right? So TypeScript is not able to provide us with useful information about iHTTP service. It has to produce an object. We cannot distinguish interfaces. And this is why you cannot use them in both Angular and Nest for dependency injection purposes. What is the potential solution, we could ask? The first potential solution would be that TypeScript compiler would, at some point in the future, leave some metadata about the interfaces in the final bundle. The problem here is that how to represent an interface which does not exist in the typical vanilla JavaScript, right? As a symbol, as a string, we don't know. So the second available solution would be to create a script which uses abstract syntax tree, AST, to statically analyze your code and give some enhanced TypeScript compiler with additional metadata only for the purposes of your framework. The problem here is that we would have to follow new releases of TypeScript all the time, and it makes it very hard to maintain. Another difficulty, generics. So again, let's have a look at our cat service. We will change the second dependency to the data source. repository class instead of logger. So now we have a repository. It's just a sort of generic class which has a specializations. The specialization here is a cat model. Cat model may have some properties inside, like ID, name, and stuff like that. Let's dive into the metadata again. And you can see that we lose knowledge about specialization. We've got a metadata variable, which is equal to an array with 2 elements, HTTP service and repository. What about a class specialization? We cannot distinguish generics in the metadata. How could we indicate that cat repository is needed in this context? Why not users repository? We cannot. This is why you cannot use generics for dependency injection in both frameworks. What is the potential solution? Again, the same. TypeScript compiler or using AST to give you some additional metadata out of the box. And the last challenge, circular dependencies. Let's imagine that for some reason we have a cat service which depends on doc service, and we have a doc service which depends on cat service. So as you can see clearly, it's a circular dependency. If we again try to reflect the metadata of this class, it's going to give us undefined. It's one element in the array which is undefined. Doc service is undefined right now. So the problem is that the first class always has to be defined first, and thus the second will be presented as an undefined. We cannot distinguish what kind of dependency should be injected here. What is the potential solution right now? So in order to solve this problem, both Angular and Nest provide a helper function, forward reference, which creates an indirect reference that framework can resolve later. So even though the typical metadata from TypeScript compiler will be undefined, we can use this func function to resolve your type in the future lazily. All right, we know already how the metadata is being handled. Let's talk about injector trees now. Both Angular and Nest dependency injection systems are hierarchical. Whilst Angular has a platform, ng module level, component level injectors named as element injectors, Nest has only one type of injector, a module level injector. Let's have a look at an Angular structure. When Angular creates a component C, which needs C provider for some reason, it will firstly look up component's own injector. If the component's injector lacks the provider, it passes the request up to its component's injectors. If that injector cannot satisfy the requests keep bubbling up until Angular finds an injector that can handle the request. And eventually, it will hit the global root scope, like this provided in the root, and pick C from there if it wasn't overridden at some point at some level in the component injectors. All right, let's move to the injectors in Nest now. As I said a few slides earlier, Nest has only module-level injectors. Generally, modules form a graph data structure. All relations might be either bidirectional or unidirectional. Just to ensure that everyone is on the same page, a graph is a sort of it's a data structure in which set of objects are connected by links, by pairs, and these objects are named as vertices, while these links are called edges. So taking a step back to our modules visualization, it's actually a directed graph structure in each vertex represents a single module. So it's a sort of, it leads us to a conclusion that each module is a singleton, which is partially true, but it's not always the case, because we have dynamic modules, for example, which are configurable. Then we have multiple instances of each module. Anyway, so every existing module has its own injector. And each module has also its own API, which acts like a facade. In order to expose a component in Angular, we have to put it into the exports array, right? In Nest, if you want to expose a provider, you have to put it into the exports array. That's the public API of the module. So it means that only explicitly exported providers are available outside of the module. If module registers a provider but does not export it, then it will be encapsulated inside and will be not accessible for any other existing module. When Nest is trying to resolve your dependency, it will firstly look up a provider within one module. Then it will bubble up, similarly to the Angular. And it will bubble up to the imported modules. Even if a provider exists in one of these modules, Nest would not be able to resolve it unless it is exported by the host module. So it has to be inside this exports array. This is how the encapsulation isolation works in Nest. Additionally, Nest also allows you overriding providers at every level. So you can, for example, if these two gold injectors contain provider registered with the same token, Nest will always use this provider, which has been defined closer to the inquirer. So for example, if you are looking for user service inside the application module, the user service probably will be in the users module, right? But if you override it inside the application module, it's going to take this one because it's closer to its own injector. Even though Nest is very strict regarding isolation levels, there is still a way to create a sort of global scope as in Angular, which would work almost the same as in Angular. If you change your module, for instance, core module, this one in the left corner, to a global one, which boils down to adding a one single decorator, which is actually a global decorator, which is very simple, Nest will create virtual edges to this module from each existing module. Nevertheless, even global module has to explicitly export providers and thus make them publicly available. So if you do not export it, they will be not public for everyone. OK. I would like to spread a few words about things that are coming shortly in the next major release of Nest, since they heavily concern dependency injection system. And the next major release will be published in the next 2 months. So I think that is great to just show you what is coming very, very soon. So far, everything in Nest has been shared across incoming requests, if you take a look at the HTTP application. Generally speaking, each provider behaves like a singleton between every request. If you have, let's say, user service, each request would obtain the same instance of this class. It might be strange for people coming from Java or C# when we mostly have a thread pool, and each request is processed by different thread, and we try to avoid this using the same instances across different threads to do not have race conditions and stuff like that. Node.js has a different execution model, though, that allows us using different concepts. So by default, we do not have to create instance for each request separately. We don't have to have a connection for each thread. We can just have a connection pool. Still, there are some very specific particular cases when you might want to take advantage of request scope providers. For example, data loaders in GraphQL. When you want to hold some sort of request level cache, which shouldn't be shared across requests. It should only exist for this one particular request. You don't want to fetch the same data from the database multiple times to do not affect the performance. And you cannot use singleton for that. So another example would be a factory, which, depending on the properties extracted from the request, connects to a different database or maybe create a different object. For example, different clients should use a different instance of their data source. So in the next release, you will be able to explicitly set the scope of the provider by putting this object directly into the injectable decorator with a scope property. Request scope providers and all classes that depends on it. So for example, if we have a cut service and we have a cuts controller which injects cut service, it's going to implicitly be request scoped as well. So it means that every time when the request hits the application, we'll create an instance of this class again and again and again. And all of them will be garbage collected right after the response. Additionally, in the next release, we will add transient scope, which means that a new instance of the transient provider will be created every time when anyone asks for it. For example, normally, provider B, C, or D would share the same instance of the provider A. But if you want to have a separate instance for each provider, you can just set the scope to the transient scope, which then would indicate that, hey, create me separate instance for every inquirer that has asked for this class. Lastly, I would like to say that Nest is open source. Just recall that, meaning that we are totally driven by the community. And therefore, I encourage everyone who shares similar ideas to join this little revolution. We would love you to contribute to Nest and help make it even better than it's today. And there is a couple of companies and almost 100 people so far, who decided to support us with their donation, which is incredibly awesome. I'm really thankful. A big thank you to all of them. And thank you for your attention.
That was solid. Yeah. Reflection, abstract syntax trees, speaking my language.
And then even just like talking about all the good that's coming too. And honestly, you know, all I've heard from this conference, like in almost every talk, Nest.js gets brought up.
Yeah, I'm really excited about that Nest becomes a player in the Angular community.
Yeah.
That people started to realize that maybe there is a way to become a full-stack developer and share the same knowledge, share the same language patterns across different sides of the development. Just super awesome. Sometimes it makes me really stressed when I'm sitting and listening to someone who's speaking about Nest. It's even more stressful than staying on the stage. But I'm really happy about that.
Well, they've been saying nothing but good things. So
yeah, but
shouldn't be too stressed.
Yeah, yes, exactly. If they decide to say something bad, then it would be worse.
Yeah. All I've heard is good, so that's been awesome.
Yeah, really.
And it's grown in popularity. I was blown away.
Yeah, it's grown a lot, especially recently, because people realize that maybe it's a good alternative solution to use, and GitHub stars is a sort of indicator of the popularity.
Yeah.
If people are putting the stars and people realize, okay, maybe it's a good idea to take a look and check. Maybe it's useful for me as well. So yeah, it grows a lot, especially during the last few months.
That's great. What's for everyone here to take away if they haven't been using Nest.js, what's your one quick selling point of what makes it so much better than all the other options?
I mean, I think that it depends on the audience.
Yeah.
Here, I would say that you don't have to learn too many things to get into the backend development. If you ever thought about being a backend development, but you were afraid that, yeah, these tutorials are so big, so huge, I don't have enough time, it's not a big deal to jump into Nest and just start using it, because so many things look almost the same. So this is super awesome.
That's great, and also very Angular-centric, too.
Yeah, very Angular-centric, that's true.
Right on. Well, thank you so much for joining us. It was a pleasure, and thanks for giving an amazing talk. And yeah, great.
Yeah.
Thanks.
Thanks so much.